Welcome to SnowEx Liquid Solutions training module, Anti-Icing Pretreatments and Performance Results. It is possible to anti-ice at 2 points during the order of operations, either by pre-treating or by post-treating. In this module, we will focus on pre-storm pre-treating, why it is a beneficial approach, the types of application equipment and materials utilized, the objective of pre-treating, the science and art of perfecting its use, best management practices for when, where, and how to execute it, and lastly, we will demonstrate performance results and associated cost benefits. According to the Salt Institute, anti-icing or pre-treating returns surfaces to bare pavement conditions more quickly, saving lives, reducing property damage due to fewer accidents, and reducing losses to local businesses. Unlike de-icing, anti-icing is a preemptive measure executed up to 48 hours before a storm. Pre-treating with salt brine is the most effective approach at pavement temperatures above 15 degrees Fahrenheit and involves spraying a light direct liquid application or DLA to bare pavement, somewhere between 18 to 35 gallons per acre, or roughly a half gallon to a gallon per 1,000 square feet. This acts as a protective coating on the surface that inhibits accumulation from forming an ice bond to the pavement, significantly expediting plowing and post-storm cleanup operations. More than just a new tool in the toolbox, preventative anti-icing represents a dramatically different approach to snow and ice control from the traditional de-icing approach. As with preventative medicine, the rationale for anti-icing is based on conclusive evidence that by investing resources in preventative measures prior to conditions getting bad, it is possible to achieve improved outcomes at less cost. Consider this analogy. You and your crew get paid according to the number of pots and pans cleaned in a designated time frame. You pay the overhead labor and material costs. Now answer the following questions. Which of these approaches will require less labor and materials to accomplish that goal? If a clean pan is a metaphor for a safe surface, which of these approaches will produce a safe surface sooner? And lastly, which of these approaches will net a greater number of clean pans or profit in a limited period of time? The answer is obvious. The approach that pretreats the pan to prevent baked-on, burnt-on grime, or in the case of snow and ice control, an anti-icing approach that prevents accumulation from bonding to the pavement. Let's take a look at the many benefits of taking a preventative pre-treating approach. First, as a proactive measure inhibiting snow and ice from bonding to the pavement, pre-treating maintains optimum surface friction and safety protection until plowing measures begin. Pre-treating is also the best prevention for high incident conditions like black ice and frost, and for protecting high accident areas like curbs and stairs. It is a more sustainable approach that requires less salt, applies with more precision, and results in less damage to customer landscape, building lobbies, and paved surfaces, all of which reduce liability, post-storm cleanup, and overhead costs, and increase profit margins. While pre-treating has been around for some time, using liquids to pre-treat is relatively new in commercial snow and ice. To get an idea of the increased coverage provided by taking a liquid approach, this map of I-95 illustrates the results achieved from using 10 tons of salt or the equivalent in brine to pre-treat sections of the highway. Highlighted in yellow are the 67 miles pre-treated at 300 pounds of salt per lane mile versus the 440 miles highlighted in blue that can be pre-treated with 20 gallons per lane mile of salt brine. Substantially more coverage using brine with faster results. SnowEx and our sister company Henderson Products offer a wide range of equipment for a variety of on-road and off-road anti-icing applications, featuring electric, gas, and central hydraulic drives. Equipment specifically designed for winter maintenance applications will help ensure success using liquid strategies. Most de-icers come in both liquid and solid forms. When it comes to anti-icing, the standard and the most widely versatile material is salt brine. According to the Salt Institute, liquid sodium chloride is the most effective choice for anti-icing at pavement temperatures above 15 degrees Fahrenheit. Also standards for low temperature performance are calcium and magnesium chloride. The most cost-effective material solution for low temperature performance is to make your own hot brine by blending salt brine with the appropriate percentage of either calcium or magnesium chloride for existing pavement temperatures. Hot brine is most effective down to a 70% salt brine, 30% calcium chloride blend, which has been reportedly used with success at pavement temperatures below zero. Lastly, CMA, or calcium magnesium acetate, is a very costly non-chloride de-icer commonly used on bridges and parking decks where chlorides are restricted due to their corrosivity to metal substructure. The goal of anti-icing is to prevent the bonding of accumulation to the pavement and to optimize friction and traction on the surface. The picture on the left illustrates the improved traction sustained on the pretreated section of this lot versus that obtained on the right side. If pretreatments are appropriately executed and plowing measures properly timed, regardless of the buildup of snow, the bottom layer should remain unbonded until plowing measures begin. The pretreating process works similarly on a sidewalk. In this example, the left side was pretreated and the right side was not. Note the improved traction of the footprint on the left, where the snow is not compacting and bonding to the pavement, compared to the footprint on the right, where as the snow is walked over, the footprints begin to compact the snow underneath. This is the beginning of the bonding process that turns to ice that pretreating inhibits. Liquid de-icers are better for pretreating because they embed in the pores of the concrete and wait for moisture. Liquids work faster because they start in solution, but they dilute and refreeze faster too due to the lower starting concentration of active ingredient. Understanding how different variables impact the dilution of a particular de-icer at a specific application rate under real-time conditions to anticipate the length of time until it refreezes is an art. Increasing application rates does not increase melting capacity, but in some cases can delay refreeze and extend cycle time. However, as a best management practice, the over-application of liquids to pretreat is not advisable and can result in slippery conditions if sufficient time for drying is not allowed. The phase diagram shown here for salt brine is a scientific tool to help understand the freeze point and melting capacity of salt brine at different temperatures and concentrations. The bottom of the V, or -6 degrees Fahrenheit, is the eutectic temperature of salt brine, or the lowest temperature at which the brine can melt ice or at which it stays in liquid form. 23.3% is the eutectic concentration of salt brine, or the highest concentration at which water will absorb and hold salt at that temperature. To the right of the V, at higher concentrations, salt falls out of suspension and crystallizes. To the left of the V, it shows the pavement temperatures at which refreeze occurs as the brine dilutes. Illustrated here by the red star, the freeze point of salt brine at 50% dilution is 18 degrees Fahrenheit, below which at that concentration it refreezes. At pavement temperatures above that at 50% dilution, the brine retains melting capacity. Again, the art here is judging how fast a particular application rate of salt brine will dilute, given the existing moisture on a particular surface and rate of accumulation at the current pavement temperature. There are 4 primary factors that impact material strategy, application rate, and timing of operations decisions relative to pretreating and dilution. The first is pavement temperature, which can vary by up to 20 degrees from the air temperature. The pavement surface is where snow and ice control is taking place. Next is the type of de-icer being used and the application rate required to achieve service goals. The performance of a chemical under specific conditions is predictable and repeatable. So if desired results are not achieved, it is not the de-icer's fault. The likelihood is that the assessment of other variables may have been in error. De-icer performance and pavement temperature are variables that can be determined by science. Next is moisture type, the amount present on the surface, and the anticipated rate of continued accumulation during ongoing operations. Being able to assess this is critically important in determining material strategy and application rates relative to the speed of dilution. Lastly is cycle time, or the length of time until you will need to cycle back to service that site again to avoid refreeze. Assessing the impact of the last two variables requires keen observation and is an art that only experience working with these tools over time can perfect. Other variables impacting these decisions are traffic and the amount of sunlight on the surface. With any suggested application rate guidelines, they are intended to be just that, a starting point from which you increase or decrease your application rate according to real-time conditions to achieve your desired performance goals. For pretreating with salt brine, that range typically falls between 18 to 35 gallons per acre, dependent on the variables discussed on the previous slide. As a rule, anti-icing should almost always be the first in a series of strategies utilized. The following are generally accepted best management practices for pretreating with salt brine. Pavement temperatures fall in the 15 to 32 degree Fahrenheit range. Time exists for the application to dry before the pavement temperatures fall below 15 degrees. Black ice or frost is predicted where you are treating high accident areas like curbs or stairs. Do not anti-ice if accumulation has bonded to the pavement. If a system is coming in as rain where the treatment can be quickly diluted. In this case, anti-icing with pretreated salt may be a better option. Pretreating is also discouraged on painted surfaces if blowing snow is forecast or if pavement temperatures will go above freezing. A good go, no-go tool for the triggering of anti-icing operations is an anti-icing decision flowchart that applies these best management practices in a prioritized manner. This example starts with the question, is snow or frost predicted? If yes, the next question is rain predicted beforehand? If that answer is yes, then you do not anti-ice with liquids. If no, it is still a go to anti-ice and on to the next factor. Is the pavement temperature 15 degrees or greater? If no, then you do not apply straight salt brine, but may opt for a blended brine. If yes, you're still a go to anti-ice with salt brine and on to the next factor, and so on. Like application rate guidelines, obtain and customize one of these charts to best suit the goals of your operation. It is commonly reported that a preventative anti-icing approach requires 1/4 the salt and 1/10 the overall labor, equipment, and material cost of a traditional de-icing approach, providing a better level of service sooner, as this picture demonstrates. Pretreating is executed at an optimal time before a storm starts, providing better working conditions for crews, and because it significantly reduces extended post-storm cleanup, it reduces crew fatigue and accidents that often follow as a result. To further illustrate the comparative efficiency of DLA pretreating versus the traditional de-icing approach, this 5-yard truck of salt will make approximately 4 1,000-gallon trucks of salt brine. And each of those 1,000-gallon trucks of brine used to anti-ice produces comparable results to another 5-yard truck of salt used to de-ice. One 5-yard truck of salt turned into salt brine doing the same job as 4 5-yard trucks of salt. In this real-world example from Minnesota, the property on the right was pretreated and the one on the left was not. In these pictures taken 5 minutes apart, which site has a better level of service? How much longer using the traditional de-icing approach will it take to achieve a comparable level of service on the left property to that already achieved on the right? Now let's look at the costs involved. Costs are estimated based on $70 per ton of salt and 8 cents a gallon for salt brine and are not actual data relative to these images. Using commonly reported application rates for de-icing of 500 to 1,000 pounds of salt per acre, it would cost approximately $17.50 to $35 per acre to de-ice the property on the left, versus using 18 to 40 gallons of salt brine per acre at a cost of $1.44 to $3.20 to achieve superior levels of service sooner. To put that in another perspective, let's examine the potential profit generated by 1 ton of salt, or its equivalent of 870 gallons of salt brine. Here we are using the same application rates for pretreating and salting as those on the previous slide. Billing at $100 per acre per application, 1 ton of salt for traditional salting grosses between $200 to $400 per acre, while pre-treating grosses between 2,200 to 4,800. Which of these approaches puts more revenue in the bank? Sidewalks are typically a high profit, high liability area. The traditional approach to servicing these surfaces is to utilize high volume applications of costly ice melt products made predominantly of calcium and magnesium chloride. These are very hot and burn off ice quickly, but in solid form are often shoveled or blown into landscape, causing substantial damage. They are also more harmful to concrete due to volume and freeze-thaw impacts. By pre-treating with salt brine or even enhanced salt brine, it is possible to reduce the amount of chlorides required to provide safe surfaces by up to 75% and reduce pavement impacts. Additionally, because liquids apply directly to the pavement where they dry, they are not shoveled or blown into adjacent green spaces to damage them. This slide illustrates the comparative cost benefit of taking a liquid versus granular approach to pre-treating 1,000 square feet of sidewalk using commonly reported application rates. Again, for this example, we are using baseline costs of $70 per ton for salt and 8 cents per gallon for salt brine, and $8 per 50-pound bag of ice melt. Using blended ice melt at 20 pounds per 1,000 square feet, it would cost approximately $3.20, whereas using salt brine at 1 gallon per 1,000 square feet, it only costs 8 cents for the application. An 88.5% reduction in salt at a 97.5% reduction in cost. Even using enhanced salt brine, the chloride reduction and cost savings would be substantial. This example compares the costs of taking a preventative anti-icing versus a traditional de-icing approach for a 1-acre parking lot. The pretreatment of salt at 35 gallons uses 80 pounds of salt and costs $2.80. For this example, we also factor in a light maintenance post-treatment of 150 pounds of salt costing $5.25, for a total of 230 pounds of salt at $8.05. By comparison, a de-icing application of 1,000 pounds of salt costs $35. The anti-icing approach provides a 77% reduction in salt and in cost. Please note that a de-icing approach has historically shown to require substantially more labor hours and materials to achieve results. And these numbers are reflected in actual feedback from contractors. Before he started pre-treating, Charles Glossop of Anthro Farms in Minnesota said a 50-pound bag of ice melt treated 2,500 square feet of sidewalk. Now that same bag services 10,000 square feet. Another Twin City contractor shared similar success, indicating they are working toward servicing 12,500 square feet per 50-pound bag as they continue to perfect their pre-treating processes. Jim Horning of Elber's Landscape Service in Buffalo explained they have seen some of their best results yet on stairs and sidewalks. At one university account, by adding brine pretreatments to the doorways, they've been able to reduce materials from 10 pallets of salt to 1.5. Jim Holm, manager of grounds and site services for the 36-site Park Nicollet healthcare system in Minneapolis, indicated that since implementing pre-treating and pre-wetting as standard practices, they have achieved a 45% reduction in salt usage the first year, an additional 28% the second, and a 75% reduction in the repair and replacement costs for damage to landscaping. After pre-treating the main campus sidewalks following a 3.5-inch snowfall, they were able to successfully broom off walks and did not need to salt afterward. Furthermore, they have been able to dial back the salt needed to post-treat their lots to 150 pounds per acre. For optimal success implementing pre-treating strategies, identify the best entry point for your operation, whether on sidewalks, parking lots, or both. Decide whether to limit services to a few select sites until you're more familiar with how liquids work and have worked out any challenges presented before making broader changes to operations, or to go all in and implement pre-treating across the board. Educate the property owner on what to expect and the nature and timing of operations and the benefits they can anticipate to get them on board. Invest in equipment specifically designed for winter maintenance applications with functionality to control material output and document it by site if possible. Set realistic expectations when training your crew. Most often, failure results from expecting too much too soon and not allowing time for perfecting the art of using liquids, which only experience using these tools over time can provide. Lastly, establish a phased implementation program to monitor event and site-specific results, building on lessons learned to continually improve material application processes, performance outcomes, and cost savings. To summarize, a preventative pre-treating approach provides significant benefits for both the contractor and their customer. That approach has been shown to provide improved levels of safety protection on sites until plowing measures begin and safer working conditions for contractors' crews, to significantly reduce labor, equipment, and material costs and increase profit margins. Lastly, to reduce property damage from salting and the associated repair and replacement costs. Thank you for your interest in liquid solutions. For more information on liquid strategies, please see the operations modules on post-treating and making, storing, and using brine.